Now, pieces of what we are about to do are going to look really, really familiar to you because we laid the groundwork for this a while back. The directions say sketch. So we are going to sketch. Now, the pieces that have to be in the sketch, all of the sketches that we're getting ready to do now, and these are going to look different. These are obviously, they're not polynomials. See how they have a variable in the denominator? So they're not going to be the hills and valleys and bounces and all that. These pictures are totally different because they're what we call rational functions, not polynomial functions. Okay, so here's the list of stuff we have to have every time. We have to have the x-intercepts. We have to have the y-intercept. Yeah, this is the first one. This is the 2-6 notes, the back of page 19. So we need the x-intercepts, the y-intercept. We need a vertical asymptote. Horizontal asymptote. And you can abbreviate these things. I will from now on. I'm just writing them out now. And any holes. So this is all vocabulary that we talked about before. The difference is, before when we did it, I just had you list where are the vertical asymptotes and you wrote down the equations. Where are the holes and you wrote down the points. Well, now we're actually going to graph that and put together the entire picture for this thing. All right? So, does anybody remember anything about that stuff? We've talked about all those things before. Does anybody remember anything about any of it? We have a vertical asymptote at x equals 3. Why do we have a vertical asymptote at x equals 3? Because that's what would make the denominator 0. So your vertical asymptote is where the denominator is 0. That's your vertical asymptote. So all of these problems now in this section are going to have denominators. In any place the denominator is 0 is going to be a vertical asymptote. Do you think it's possible to have a problem with more than one vertical asymptote? Yeah, if you have to have 2 things in the denominator, for example. Okay, good, very good. Anybody remember anything else about this? The horizontal asymptote is y equals 1.
Oh, it's a rip.
And I know the horizontal asymptote is y equals 1. That's the thing where you put the x over the x, remember? Let's review those rules. Since it's 1x over 1x, it's just 1. If it had been 2x plus 3 over x minus 4, that asymptote would be at 2. What if the power on top were bigger? Uh-oh. No, then there's none. There's no horizontal asymptote if the power on top is bigger. If the power on the bottom is bigger, the asymptote is at 0. Okay, remember, you gotta remember those rules. We're not going back through them. We're supposed to kind of remember those. So we're refreshing your memory. The powers match. If the powers match, you just make the fraction. So this one would be 2x over 1x or 2. The one we have is x over x, so that's just 1. If the power on top is bigger than the power on the bottom, then there is no horizontal asymptote. If the power on the bottom is bigger than the one on top, then the asymptote is at y equals 0. Okay, So we got our horizontal asymptote here. Okay. Anybody remember anything else about the rest of it? What if I said to you this problem has no holes? Do you remember why not? What has to happen for there to be holes? You have to be able to factor and cancel. You can't in this problem, so there aren't any. You're not going to have any holes unless you can factor and cancel within your problem. This problem's too small. There's no canceling that's going on here. What do I mean by intercepts? What is that talking about in terms of the picture? What are intercepts? Where you cross an axis, right? Right?
Yeah.
So think about this, guys. If you are on the y-axis, if you're a point on the y-axis, what do I know about you? Whether you're that point or this point or this point, what do I know about all those points? What's the x-coordinate? 0. Isn't the x-coordinate going to be 0? For any y-intercept, x is 0. What about for an x-intercept? Y is 0. So this is how you find your intercepts, guys. You simply let the other letter be 0. So in other words, if I am looking for my x-intercept, I'm going to let y be 0. So then I have the equation 0 equals x plus 2 over x minus 3. Now I want to get rid of that fraction, so I'll multiply over here. Well, what happens when I multiply this over to here?
Just get 0 over
It's
there.
still 0.
Negative 2.
-2. So my x-intercept is at -2. Now my y-intercept, when you find an intercept, you let the other letter be 0. So to find my y-intercept, I'm going to let x be 0. What do I get if I put zeros in for the x's?
2 over negative 3.
2 over -3. Now, think about your BFFs. You had a BFF and had an x in the denominator. Do you remember what that looked like? That was called your reciprocal function. Do you remember what it looked like? Max, do you remember? I see you thinking there.
Wouldn't it, I probably like drew the wrong thing, but like wouldn't it like sort of be like this?
You know what? I have my glasses on, so I gotta come back and see.
It like starts from the bottom and then it goes out?
No, that would be, that is a picture of the logarithmic function, so that is one of your BFFs, but it's not this one.
Okay.
No one remembers what the oh yeah, Rylan?
It's a line in the, I forgot which quadrant it is, but it's a line here and a line here.
Perfect. She's got it. This is the reciprocal function. Remember that guy? Okay. These equations are versions of that, so they're going to have kind of that shape, but things are going to be switched around a little bit. See if you can see it. If I connect these two dots and continue my line to follow those asymptotes, can you see an arc right there? I mean, does that kind of make sense to you? Where's the other half of the picture then? Remember, reciprocal functions have two halves. Where's the other half going to be? Up here? And there is a graph. There is the picture.
You don't need any specific points for the other one?
You don't. The only specific points you have to have, Joe, are the ones I have listed.
Okay.
Now, if you get confused and you're not sure what to draw, you can always plot more points, Joe. So you could, let's see, this is 3. So you could go ahead and put 4 in and put 5 in and actually like do a T-chart
Okay.
and plot points if you wanted to, but you don't have to. not there. Got it? Because now we're going to do another one that's pretty much the same thing. So now we're going to do x minus 2 over 1 minus x. All right, so here we go. I've erased everything.
You're gonna type it.
I need the same information for this problem. So tell me anything. Zion, can you tell me anything about my new picture here?
It's gonna be a positive 2.
What's going to be positive 2?
The X.
Or what x? This x? Or this x?
That one.
This one here?
Intercepts.
Yep. Zion is exactly right. Zion says if I put a 2 in here, I'm going to get y equals 0. And he's right. He's right. X-intercepts come from your numerator. Zion's exactly right. Okay, so I'll plot that. 2 comma 0. Right there it is. All right, what else can you tell me? Sam, can you tell me anything?
There are no holes in this one.
There's no holes in this problem because remember, to get a hole, you have to be able to factor and cancel. And there's no factoring there. Okay? Chandra, can you tell me anything else that I don't have?
Would y be 2 as well, or negative 2?
The horizontal, or you mean up here?
Yeah.
Okay, well, let's see. How do we find a y-intercept? We let x be 0. And if he puts a 0 in, he gets negative 2 over 1. He's right. The y-intercept is negative 2. What about these asymptotes? Jordan, can you give me an asymptote?
An app. Would it be 0 for the horizontal?
Now, the horizontal asymptote can be 0, but when does that happen? The only time the horizontal asymptote will be 0 is if what? The power on the bottom is bigger.
Isn't it just 1? So, oh, it's not. I was
Don't
looking
these
up
two
the-
powers match?
Yeah, they do. So it'd be 1.
Actually, it would be negative 1 because it's positive x over negative x.
Okay.
So the asymptote is at negative 1. It's a little tricky, but you're putting your x over your x. So it's negative 1. What about my vertical asymptote? Here, I even wrote it out. It's where the denominator is 0. Where's the denominator going to be 0?
1.
1. Alright, so I've drawn in my horizontal asymptote and I've drawn in my vertical asymptote. Can you, now remember, it's going to have the shape of a reciprocal function, so it's going to have the same shape as our last one did. Can you see that shape forming in there? See this point right here? Can you envision that shape?
Oh.
Can you see that shape?
Mm-hmm.
And then look over here. Don't I have a point over here? Remember, the curve is framed by its asymptotes. So whatever you draw is going to be limited or shaped by the asymptotes. Does that picture make sense to you? They're all gonna look like that, okay? Some version of
So
that.
you have to find the asymptote before you find it.
Yes. Before you draw anything, find these 5 things.
Okay.
If you find these 5 things, then you can jump in and draw. Okay? All right, one more. This one looks a little bit different. Now wait a minute. Max, I got an x squared over an x squared. There, they match. So my asymptote is going to be y. My horizontal asymptote is going to be y equals 1. Because it's x squared over x squared. I wonder if I have any holes this time. I might. Somebody said no. I can factor, but I can't cancel. So even though I can factor, there still aren't going to be any holes. What about vertical asymptotes? Now remember, vertical asymptotes come where the denominator is 0. Well, wait a minute. What about this? I have a denominator that'll be 0 at 3 and at -3. So I have 2 vertical asymptotes. 3 and -3. And no holes, I got my asymptotes. Well, what about my intercepts? What do you think? Zion, do you have any idea this time?
They stay the same.
You're going to look up at your numerator. So you're going to have 1 at 2. And you're going to have 1 at -2. Your x-intercepts come from your numerator, and there's 2 of them this time. How about a y-intercept? If I let x be 0, what happens if I let x be 0? Remember, to find a y-intercept, you let the other letter be 0. What happens? I get 4 9s. Okay, now remember that asymptote's at 1, so 4 9s is like right here. 4 9s is less than 1. Yeah. Oh, this is weird. You see 3 points right here? So I think we got a little parabola action going in there. Doesn't surprise me totally because I've got a square to my problem, right? But now wait a second. There's 2 more pieces of this graph. Anybody have a wild guess what the other 2 pieces look like? What do you think it looks like over here?
Half is like half right side.
It is. It looks just like this, Chandra. You're exactly right. Guess what's over there? Same thing. All right. Well, we're going to talk more about that next time. But that is actually the picture. So good job. All right. I will see you people over in the trail. Andy, would you turn your iPad off, please?